Hello there, Chem Squad. I just have a couple more factors to talk about today. The first one being a catalyst. Some of you guys who have taken biology, may already know what a catalyst is. For those of you who don't, it's a substance that speeds up a chemical reaction. Now, in order to do it, it finds an alternative pathway that requires less energy. So we'll talk more about what this alternative pathway is in a future video. Right now, I just kind of want to go through some examples of catalysts. So the one that I have in mind is enzymes. Enzymes are typically organic / biochemical catalysts, meaning that they only work on chemical reactions that happens in living organisms. So one that you might remember from bio is an enzyme that might break down starch. Okay. When you break down starch with this enzyme, there's several of them, but we use the term amylase to cover all bases here for all the different types of amylases there are. They will tend to break down starch into smaller molecules of glucose. Okay, and it does so very, very quickly. Okay, much easier than if you didn't have the enzyme present. Another good one for breaking down a substance that you guys may consume is called alcohol dehydrogenase. And alcohol dehydrogenase is made by your liver. And it breaks down alcohol into smaller organic molecules. Okay. And those molecules could be acetates or even aldehydes that your body will then get rid of through your urine. Now, most people are familiar with enzymes as being catalysts, but there is another group of catalysts called inorganic catalysts. Inorganic catalysts are not enzymes because they don't necessarily work on biological organisms or systems or chemical reactions, so they're not enzymes, but they are catalysts. So that means all enzymes are catalysts, but not every catalyst is an enzyme. So the one that I want to look at with you guys today is H2O2, which you guys should already know as hydrogen peroxide. Okay. Hydrogen peroxide will normally and naturally break down into water and oxygen gas. Okay. But without a catalyst, this reaction is slow. But if we do add a catalyst, and this catalyst happens to be an inorganic chemical called manganese dioxide. Okay, so this is our catalyst. then the reaction proceeds much more quicker. And I urge you to watch a video that I'll post showing how quickly we can produce oxygen gas if we add manganese dioxide as a catalyst. So catalysts themselves increase the speed of a reaction. Okay, they can work on inorganic reactions, okay, like what we have with peroxide, or it can work with organic reactions or biochemical reactions, okay, that we see enzymes, how they work there. So the very, very last factor, is called nature of reactants. Okay, and all this simply means is some chemicals naturally react faster or slower because of their chemical properties. So if you think about things like noble gases, okay, they're in family 8A. All of them are stable and inert. Therefore, they react very slowly. With other chemicals. Right? Because that's their property. However, if you take the alkali metals in family 1A, okay, the first column, they're very unstable because they only have one valence electron. Therefore, these guys react very quickly. In order to get rid of their one electron. So they react very quickly, in this case, with water. So if we add sodium plus water, okay, it will create NaOH and hydrogen gas. And this is a natural reaction that happens very, very quickly.